Okay, one more segment proof for you. So in this segment proof, where you have this diagram right here, and what we're going to try to show is that, what we're given is that PS is congruent to ZM. So these two little guys are congruent. Let's go ahead and mark them congruent right now. And what we're going to try to show is that PZ, this longer segment, is congruent to SM, this longer segment. Okay. Well, let's see if we can think through that for just a second to get the wheels turning before we jump in here. If I take two things that are congruent, that means they're equal in measurement. So two equal measurements, and I add the same thing to them, right? PZ is PS plus SZ, and SM is ZM plus SZ. So both of these segments that I'm getting, that I'm looking at, PZ and SM, they both have SZ in them. It's a little segment, two little segments that are equal, and then I add the same segment to both of them to get bigger segments. So those bigger segments must be equal to each other. If I have two little segments and I add the same thing to both of them, I'm going to get two bigger segments. That's kind of the idea here. So that's where we're headed, but we need to prove it. We can't just say it, we got to prove it. So over here we got statements and justifications. Okay. These are going to be the big ideas for the proofs that we're doing in today's lesson: the definition of congruence, definition of midpoint, and segment addition postulate. So let's keep that in mind as we go through. Our first statement here, is PS is congruent to ZM, because that's what's given here. And I went ahead and kind of marked that in my diagram as well. The last statement that we're going to have here is PZ is congruent to SM. When we get there, we know, as long as we can justify that step, that we're done, that we got it. Okay, so that's kind of where we're headed. Now let's, again, think about what we're going to be doing here. If I need to get PZ, I can build PZ out of two smaller segments, PS and SZ. Right, that was the segment addition postulate, which we've talked about before. So that's going to be an important thing here. If I want SM, right, at the end I want to say something about SM. If I want to do that, I can build SM out of two smaller segments. Okay, so that's kind of what we're doing here. So we know we're going to use segment addition postulate at some point. But let's start with this and see where this can get us. What does congruence tell us? What is the next step once we have congruence? Well, if we have congruence, that means we have equal measurement, equal length. Okay, so if these two guys are congruent, that means their lengths are the same. Okay, so this is definition of congruent. Okay, for the next statement, we're trying to get closer to this, to PZ and SM. So for the next statement, we're going to actually write out how do we get PZ, or what is PZ equal to, so that we can start messing around with it. So we know that PZ, the measurement from here to here, how do we get that again? It's PS plus SZ. So this measurement plus this measurement will give you the big measurement. So PZ is equal to PS plus SZ. Okay, cool. And the justification there is a segment addition postulate. Okay. We can do something similar for SM, right? If we want to say something about SM in the end, we better kind of figure out what SM is equal to and start using the pieces that we know. So SM is equal to SZ plus ZM. Okay? And that's the same reason, segment addition postulate. Now you might be wondering to yourself, how does he know where to go? There's not like a set structure for a proof. Sometimes you can change the order of stuff. Now typically that it's going to build on itself, right? But sometimes you have pieces of information that don't have to come in at a specific time. You can bring something in later or earlier, as long as you put it all together. So we're just kind of gathering some ideas right now, and as you get better at doing proofs, you'll start to see, oh, I think I need to do this next. Or this is a hint that tells me I need to do this. So, like this, for example, every time I see congruence, usually my next step is to just use definition of congruence to get into equality land. If I'm talking about segments, sorry, let me just redraw this congruent here. If I'm talking about segment pieces, I kind of like figure I'm going to have to build those segment pieces with the smaller pieces and see what that does to me. Okay, so that's kind of where we're at. Now what we want to show at the end is that these two things are equal. Okay, so that's kind of what we need. If we can show that this is equal to this, then we can use a substitution to show that these are equal. So this is kind of a tricky step, but let me kind of show you what's going on. Think of this right here as an equation, right? Let's do it like, let's write it out like this. X equals y, right? Would it be legal to go plus 5 plus 5? X plus 5 equals y plus 5. Yeah, we could do that. That's the addition property of equality. Two things are equal to each other. I can add the same thing on both sides and it's still equal, right? We balance out the equation. That's something that we do all the time with algebra. So I'm going to do that here, but it's going to look a little bit different than normal. Okay? Here's what I'm going to do. What I'm going to add to both sides is I'm actually going to add another segment measurement, right? Because I have PS and ZM. What am I trying to add to both of those? What I'm trying to add to both of those segments is SZ, right? So I'm just going to add that to both sides, which I can do because of the addition property of equality. So you would normally show this, but I'm going to do plus SZ plus SZ plus SZ, right? On both sides. I can do that. And I'm going to write the result that I get way down here. So this is PS plus SZ. And on this side, I have ZM plus SZ. Right? So we got that going on there. Now, we don't really have to order this a certain way. The addition property of equality, the commutative property of addition, commutative property of addition says the order doesn't matter. We don't actually have to state that property right here, but just so we're all clear, I can equally, or just as easily, write this as SZ equals ZM. And if you really wanted to, you could say, oh, I'm using the commutative property of equality, but you don't really need to do that. Sorry, one more time. SZ plus ZM. Okay, so what do? We took two things that were equal and we added the same thing on both sides of the equal sign. Again, that's the same thing as saying if these two things are equal, I'm allowed to do plus 5 to get x plus 5 equals y plus 5. All right, that's exactly what I'm doing here. Same thing. Remember that all of these things are just numbers. They just represent some number, some measurement. Okay? So I took this guy, I added the same thing to both sides, and now I'm down here. Well, what does that allow me to do? Well, check it out. PZ plus SZ, that's this guy. SZ plus ZM, that's this guy. So what I can do now is I can replace this with what it's equal to. Right? PZ equals PS plus SZ. And then SM is equal to SC plus ZM. So I can take this piece, again, the notation you're not going to really include in your proof, but I can replace this guy with PZ. And I can replace this guy with SM. What property allows me to do that? The substitution property of equality. Actually, we need to use that. We forgot to add the addition property of equality here. Right, that's what we did. Addition property of equality. Added this to both sides. We forgot that justification. I got excited. Okay, then here, this is the substitution property of equality. Okay. And then down here at the bottom, how do we get from here to here? If I have PZ equals SM, how do I get to PZ segment is congruent to the segment SM? That's the definition of Kong again. Definition of congruence. Our two measurements are equal, then they're congruent. Okay, so notice that we use some algebra in here. We use the addition property of equality and the substitution property of equality. We couldn't do that if we're in congruence land because there's no addition property of congruence and there's no substitution property of congruence. We have to switch over to equality, which happens in here, and now we're doing some algebra stuff. Okay, so we start with geometry, we end with geometry. This is geometry in the middle, but it's like we're doing algebra on segment measurements, which kind of becomes an algebra problem. So that's kind of an example of a proof. Now you're going to have one that's real similar to this in your homework. So use this as an example. When you see this setup, something that looks like this, this is kind of the order that you're going to get. And I just want you guys to be able to understand this enough that you could kind of like rewrite it, like copy it over. I wouldn't expect you to do this all on your own just yet, or give you like a new one that you've never seen before and expect you to be able to come up with all of that. But I do want you to be able to like understand and like copy it, or copy that technique, copy those steps. So if you need to, go back, rewatch that one again, go through the steps so you can figure out, wait, what happened here? Oh yeah, addition property of equality, or how did we get from here to here? Because it's a difficult process to start learning how to do this, but a lot of it is just going to be gaining experience. The more you do it, the more you'll understand it, the more it'll make sense. We're building deductive reasoning muscles here. We're pushing our reasoning and our logic skills. We're developing those skills. So stay with it, practice, and you'll get better.